Today we're going to determine the formula of a hydrated ionic compound. We have here cupric chloride, and the label tells us it's a dihydrate. We'll find out if our experimental results match that. So, copper 2 chloride, we are going to heat it gently over a flame in a stainless steel crucible so that we will have all of the water evaporated off, and then we will take the difference between the mass to find out if the number of moles of water was exactly twice that of the number of moles of copper chloride. So the first thing we need to know is the mass of our crucible. I'm going to use an analytical balance here because I happen to have it ready and available. Let's make sure we set it to 0 before we start. So the initial mass of our crucible, 25.1346 grams. Now I'm going to add some of our copper chloride. The exact quantity we measure doesn't matter too much, just so long as we know how much we've put in. That should be a decent amount. I'm going to take this back. I have re-zeroed the analytical balance to the mass of the crucible. So we'll put that in there. And the quantity of copper chloride we've added is 2.2066 grams. We're back at the ring stand now. I'm going to set my crucible in here, and since I want to heat it very gently, I'm going to raise it up a little bit farther above the flame. There's always the risk of overheating it, and when you overheat one of the hydrates, they can oxidize or have other side reactions with the gases that are in air that we don't want to happen. So I will now turn on the flame, and we will gently heat this for a little while. There should be a distinct color change when the water is removed from the hydrate, and we'll check it occasionally every minute or two to see how it's doing. Alright, it looks like we have gotten rid of all of the green color, which is an indicator that the water has been completely driven off. Now we will let it sit and cool for a few minutes before we put it back on the balance to see what's left. Okay, the crucible's had plenty of time to cool off, so we're going to take it over here and find out what the final mass is. Remember, I reset the 0 on the balance to the mass of the crucible. So we now have 1.7913. Okay, it's time to do the calculations. I have put up on the board the original amount of our copper chloride hydrate solution was 2.2066 grams, and we know that the formula is CuCl2, and it is some number of water molecules that goes along with each formula unit of CuCl2. We heated it, driving away the water. That left us with 1.7813 grams of just CuCl2, and I subtracted that from our original because the difference between these two numbers is the water that was driven away, and that is 0.4153 grams of water. In order to make a valid comparison, we need to convert each of these into units of moles. So we start with 1.7813 grams chloride, I know that 1 mole of copper chloride has a molar mass of 134.452 grams. We do the same thing with water. And the mass of 1 mole of water is 18.015 grams. And that will give us .13323 moles of copper chloride, and this turns out to be 0.23053 moles of water. Now we want to find out, this is a 1 to something ratio, because for every 1 copper chloride, there is a certain number of waters. This isn't an obvious 1 to something ratio, so in order to figure it out, we divide both by the smallest number. And when you do that, we get this is 1 and this is 1.73. Now, due to experimental error, the 1.73 we can round up to 2. We probably want to go back and redo the experiment a few times to see if we got that number consistently or if we more frequently got near 2. But what this means is our final formula should have a 2 in front of there as a dihydrate. And if you remember from the beginning of the video, when we looked at the label, it said that it was a dihydrate, so our experimental result supports the information that we read on the label.